We discussed question 8 of A-Level Pure Mathematics 3, Paper 3, in May and June of year 2020. A certain curve is such that its gradient at a point is proportional to y over x square root of x. This gradient means that the derivative dy dx is proportional to y over x square root of x. The curve passes through the points with coordinates 1, 1, and 4e. Part A, by setting up and solving a differential equation, you need to find the equation of the curve expressing y in terms of x. Gradient is proportional to y over x square root of x. Gradient is given by dy dx. This is proportional to y over x square root of x. We can write dy dx equals a constant multiple of y over x square root of x. This is a differential equation, and over here, if you look at the denominator, x square root of x, that is x to the 3 over 2. Use the law of exponent, x to the 1, x to the half. 1 plus half gives 3 over 2. This differential equation can be written as kyx to the negative 3 over 2. And we can rearrange so that 1 over y dy dx is kx to the negative 3 over 2. Integrating both sides with respect to x, we have 1 over y dy on the left, and on the right, we integrate kx to the negative 3 over 2 with respect to x. The integral of 1 over y with respect to y is ln of the modulus of y. And for the right side, we have kx. So we increase the exponent by 1, that is negative 1 over 2. And you divide by the new exponent here, plus a constant of integration. We have ln y equals negative 2 kx to the negative half plus c. Or we can write ln of the modulus of y equals negative 2k over square root of x plus c. We need to find the values of k and c. We are given that the curve passes through these 2 points here. The first point with coordinates 1 and 1, we replace x and y with 1, so that you have ln of the modulus of 1 equals negative 2k over square root of 1 plus c. Ln 1 is 0, and we have 0 equals negative 2k plus c, or c is 2k. That is the first equation. The curve passes through another point with coordinates 4 and e. We replace x with 4 and y with e. So we have ln e equals negative 2k over square root of 4 plus c. Ln e is 1 and square root of 4 is 2. That is negative k plus c. That is equation number 2. We can substitute c equals to 2k from equation number 1 into equation number 2, so that 1 is negative k, c is replaced with 2k, and from here we see that k is 1. We substitute k equals 1 into equation number 1 to obtain c equals 2. So we have k equals 1 and c equals 2. Then this equation here, ln of the modulus of y, k is 1 is negative 2 over root x plus 2. We need to express y in terms of x. So rearranging, we have y equals e to the negative 2 over root x plus 2. That will give us the differential, that will give us the equation of the curve for part A. Part B, describe what happens to y as x tends to infinity. Now we'll use this equation of the curve here, and we see that as x tends to infinity, the exponent 2 over negative 2 over root x, this approaches 0. Then we say that negative 2 over root x plus 2, which is the exponent for the curve y, that is going to approach 0 plus 2, which is 2. And y, which is e to the negative 2 over root x plus 2, this approaches e to the 2, since the exponent approaches 2. So we say that as x tends to infinity, y tends to e to the 2. You can write down as x approaches infinity, y approaches e to